Right, question 37. Now, this looks slightly different to the previous one. It's not as if we've got something to the power x on one side and then something on the other side, where you would then take logs of both sides. Something completely different here. What I want you to notice with this is, if you look at it, it almost sort of feels like a quadratic sort of setup. Okay, it doesn't really look like it at the moment, but you can see, you know, we've got three terms here, haven't we? And that term there, we're adding on a constant. Okay. So let's see if I can change this into a quadratic. Now notice you've got 3 to the x here, 9 to the x here. Now what's common between these two numbers, of course, is 3, okay, because 3 is a factor of 9. In fact, we could rewrite 9 as 3 squared. So we could actually rewrite this whole thing as this. Okay. So I haven't changed anything apart from the rewriting the 9 as 3 squared, okay? There's a reason why I've done that, simply because I've got a 3 here and I want to try and link these two terms here, okay? Now, when I've got this here now, 3 squared, you see then I've got 3 to the power 2 to the power x. When you've got one power raised to another, we're actually multiplying them. Okay, we're multiplying them. And when you multiply powers, it doesn't really matter what order you do it in. Okay, so I could even now rewrite this as 3 to the power x squared, take away 6 times 3 to the power x plus 8 equals 0. Okay, and now if you notice, right, it is definitely looking like a quadratic now, because you've got this thing here squared, take away 6 times this thing plus 8 equals 0. You might not be convinced with me that this looks like a quadratic. What I can do though, just to make it look more like a quadratic, if I, just for instance, for the minute, let 3 to the x, okay, equals, let's just make it a different letter, right? Let's just say 3 to the x. Let's just make it equal to u, okay? There's a reason behind this. Let's just say 3 to the x is just equal to u. I've made this up. But if it's equal to u, then I can, instead of saying 3 to the x, I could squared, I can say u squared, okay? And then you've got 6 times, well that's u, isn't it? So it'll be 6 times u, which will just be 6u, plus then 8 equals 0, alright? And now you can see it's a quadratic. This is a quadratic in u, okay? Of course we know this is what u is equal to, but ultimately it's a quadratic format. So what I can do now is factorize, okay? Put it into two brackets, and we find two numbers that multiply to give 8 and then add up to give minus 6, so that'll be minus 2 minus 4, okay? So then we have u minus 2 equals 0, or u minus 4 equals 0. So that means u is equal to 2, u is equal to 4. Now we've got answers. However, of course, we want to work out what x is, don't forget. You know, u is just something I made up, okay? It's a temporary thing, it's a temporary measure just for us to see this quadratic. So what I'm going to do now is I'm going to replace u with what u actually is. So remember, u is just 3 to the x. So I've got that, haven't I? And the same here, 3 to the x equals 4. Now I've got this to solve. Of course, with this now, we can just quite simply take logs. It's really straightforward. So we take logs of both sides. Okay, of course with the logs then I can bring that x down as a power, bring it down, multiply it by the log 3, so then you get your x equals log 2 divided by log 3, so x will equal then, get my calculator, log 2 on the top, log 3 on the bottom, and I get 0.63 to 2 decimal places. I'll do exactly the same for this result. Remember, we're going to have two results to look at here, so we take logs on this side, log 3 to the x equals log 4, and then bring the x down, so that'll be log 3 equals log 4, okay, and then x will equal log 4 divided by log 3, so x will equal whatever that is. So let's have a look, log 4 divided by log 3, which equals to 1.26 to 2 decimal places.